Hi, everyone. Sorry for the delay between traffic and technical issue. We are a little late, but we are going to catch up. I would like to welcome you in this consecutive session of our, let's say, monthly meetup in relevant topic in data science. The today topic is data science with Spark, and our presenter is from Big Data University. So he's going to present himself with short bio before starting. Say it.
Sure. Thank you. Okay. So I will just give you a short bio about myself. I'm data scientist in Big Data University team. I'm sure that in previous meetups, my colleagues came here. I think one time Polong has came here, one of our data scientists. I think another colleague of me, I don't remember his name. I don't know, what was our colleague that came last time instead of me? Yes. He also came one time for me, and I'm sure that both of them have introduced Big Data University to you guys. Still, I go one more time to Big Data University, and I quickly talk about that one. What we are going to do today is I just give you a bit introduction about data science skills and tools, and then I give you one example of data science project, and we jump to hands-on session. We start from beginner of Spark, and we do some hands-on parts in our virtual lab. So let's start with data science. As you know, data science is an interdisciplinary field to extract knowledge or insight from data. This data can be big data, small data, and actually it's a continuation of some data analysis work. For example, data analysis, data mining, and so on. Essentially, we have two types of data science. First type is that when we have a problem and we have a data and we try to find some insight from that data, we call it problem-driven data science, right? For example, I want to increase my sales. I have a lot of data for my chain store, and I want item X sells more than item 1 on some days, so I will do some data mining or data science on my data to solve the problem. The second type of data science problem is we don't have any problem. We just have a lot of data. We try to dive into that data and find some interesting things out of this data. So about data science trend, as you know that it's like very hot topic nowadays. For example, in Glassdoor, it has been ranked as top job, first ranked job, and it's based on the number of job opening and like based on the salary. So the question is that like other than that, Harvard Business Review just announced that the data science is the sexiest job of the 21st century. I don't know that you can see that one sexy or not, but sometimes it's not really sexy because you have to deal with many inconsistent data, big data. You have to come up with new algorithms. You have to learn a bunch of skills, right? And it's sometimes very hard. But as this personally, I'm very excited to just do the data science and find some insights out of data. So what are the application of data science? So the first application of data science definitely is industry, right? Let me tell you a true story. A few years ago, I used to work in insurance company, right? I was just graduated from Master of Computer, and a company approached me and told me, say, we just found that data mining is very good and can help us in insurance. The problem is that we have some kind of fraud in our system. Our profit is very good, so we don't care if we have some kind of a small fraud in our system, but it's very bad for our reputation. right? Can you help us to find this kind of fraud? And even though I hadn't enough experience, I accepted that one because I just Googled it, that how people do the fraud detection. I say it's very simple, right? You just find some patterns of the fraud, right? And after that, you can detect that kind of fraud. Exactly the same the way that is done in banking system, right? For example, if you have many transactions in your credit card, bank will call you. They'll say, hey, are you the one that are doing that one or not? So they have some kind of patterns for us. So I said, I can just do that one for insurance as well. So I accepted that one, and I just landed on the job. And after that, I started understanding that what's the problem. The problem was that that insurance company had many, many representatives in all the cities in the country, right? And they were focusing only on car accidents. So when one accident happens somewhere in the world, they will report this one to the headquarters, right? And over there, they made decision that how much they have to pay for that problem. So I started working on that, and that time I found that there is no pattern for finding this kind of fraud. It's completely unsupervised, right? And it was very different from the way that people find in banking system. Anyhow, I did some kind of magics, and I analyzed that data. I went to my manager and told him that, okay, I have a good news and a bad news. The good news is that I have found some frauds, and I've confirmed with experts, with inspectors of the insurance, and they said, yes, this one is fraud. But the bad news is that it's not our client who are doing that kind of fraud. It's our representatives in other cities, right? Insurance representatives who are doing this kind of fraud. So it's why I'm saying that sometimes when you are doing data science things, you have problems, but when you are solving that problem, you find some other interesting things, and you can use it for that company or for whatever it has. Data science also have some applications in social good. I maybe later explain about this one later. And also nowadays we have data science for data journalism. And what we are doing in IBM with big data and Spark. In fact, IBM has announced a major commitment to Apache Spark, and we call it potentially the most significant open source project of the next decade. So we find that we usually have two problems in working with big data. The first problem is lack of skills. Like if I'm a fresh graduate from a university, it's very hard to find that the right skills for data science, because you have to learn many different languages, different tools, different algorithms, and different domains to be expert in. And another problem is tools. You have to use different tools, and you find the best environment for yourself, right? We try to solve these two problems in our team. So for the first problem, we came up with bigdatauniversity.com. If you go to this website, bigdatauniversity.com, is like a MOOC, like other MOOCs. There are a bunch of them on internet, like Coursera, and many other MOOCs that exist there. We also have one virtual university, I can call it, but our focus in this Big Data University is mostly big data and data science. So we have Spark courses, Scala courses, R, Python, Hadoop, and many, many other different courses. So what's different between our Big Data University and other existing systems? First of all, it's free. All of the courses and all of the materials in this website is free. You can take each course and finish it at your pace and your place. At the end of each, we have a concept of learning paths. Instead of focusing on courses, we have learning paths. For example, if you want to learn R, how you can start that one. So we have created a learning path. You first go and take the introduction to R, then you go for data analysis with R, data visualization with R, machine learning with R, and finally Spark with R. So it's a learning path. So instead of focusing on course, we have focused on learning paths. and you, at the end of the learning path, you get one badge from IBM. We have started in 2010, and now we have more than 500,000 users who are working with Big Data University. So, for example, if I want to learn data science, I don't know anything about data science, I can take one of these learning paths. After passing each course in the learning path, you get one certificate. For example, we have a learning path that has 4 courses: Introduction to Data Science Methodology, Data Science Hands-on, Open Source, and finally Introduction to R. And at the end, you get one badge. We have a learning path for Spark as well, and it's Spark Fundamental 1, Spark Fundamental 2, and Spark for R programming. The thing is that we try to have courses very short. It's not more than 5 lessons or modules, and each module has 5 videos, and they are not more than 5 minutes. So the whole idea is that if the courses are shorter, the chance you finish it is much higher. Like, for example, you go for a break from your job and you just take one of these videos and look at that one and you finish the course. So let me just go for the second problem, which is tools, right? I told that for SQL we have Big Data University. For tools also we have datascientistworkbench.com. I hope that you have registered for datascientistworkbench.com. Have you registered? Yes? If you have, just raise your hand. If you didn't, just go to datascientistworkbench.com and register for this website. It's very simple and straightforward. Datascientistworkbench.com. We will use that environment to practice Spark. So it takes 5 to 10 minutes to register that one. Meanwhile, I am going to tell you another story, right? That's why data science is important. A few years ago, 8 years ago, I had a project. I was working on a project, and the project was predicting of Forex market, right? It was a time series data. And if you have passed bachelor in computer, statistics, or math, you can see that it's a very simple and a standard problem that most of people start working with that or try to solve that one. And the whole idea is that if you have a time series and you have some values for that, you can use that history data to predict the future, right? There are 2 approaches for solving this problem. The first approach is technical approach. Usually you can use neural network, averaging approach, or hidden Markov model to predict the future, right? But I didn't want to use that kind of mathematical modeling. I wanted to use data science modeling. And what is that one? I thought that, okay, how this time series data will change over time, right? And I found that usually some events in the world will happen on a stock market or Forex market. For example, the oil price goes up, so it will affect the market, right? Or, for example, we have a war, or we have, for example, election in USA, so it will affect our time series data, right? You saw that, in recent election, how the markets went up and down. So I wanted to use this outsourced data, right, and see is there any relation between this kind of data and movement of market or not. And where can I find this kind of outsourced data? Do you have any idea? News, right? I can easily read many news and see that is there any relation between text in news and the movement of market or not. So I started collecting a lot of text from Google.com, from the news from economy, from market, all of this kind of news. And I try to align this news with movement of my market to see whether is there any relation between these two or not. So the whole idea was that if I have a lot of text, right, and I have a movement on my market, I use this kind of text when they are released, okay, to predict my time series. So if I could make a model based on all of this text that comes into news, I'm trying to predict the future, right? So how did I approach this problem? The first step was slicing this data. Maybe you cannot see, but I've sliced all of my data in 1.5 hour chunks, right? For this part is one chunk, this one is the second chunk, third chunk, and so on. So for these chunks, I found the averaging of my movement. For example, here my market is coming down by average. This one is going up, down, up, and so on. Does it make sense? Yes? Okay, good. So then I went to each chunk and find some keywords which are very important in this, for example, 1.5 hours. And when I say that it's very important or very significant, you can imagine that the keywords are repeating mostly, right? For example, we have demonstration in Hong Kong. There are war, gold, I don't know, election, Trump, whatever that we have, right? And if we can find some connection or relation between these keywords and up and down in my market, I can later use to predict this part of my data, right? So it's very simple. I just made a table, start from, to, and all of the keywords and whether it's going up or down. Finding these keywords is very simple. You can easily use TF-IDF, which is like time frequency of the keywords, to create such a table, right? And if you make such a table based on what you have seen here, right, you can easily make your model, your classification model. So if I make the model from my records from 1 to 25, later I can predict record number 25. Does it make sense? Yes? Okay. You can use different types of classification models to train your data. Neural network, support vector machine, decision tree, whatever that you know. So as you can see, I've followed the whole data science methodology, right? I've started understanding the business, then I find my analytic approach, data requirement, understanding of data, and I start making my model. So I start implementing my model. And for implementing, I've started scraping some news with Python package. I did some vectorization. Vectorization of news is just converting this kind of keywords to some numbers, right? And cleaning, exploration, merging with file time series. Then I use Weka to do the classification. Are you familiar with Weka? That time was very popular for data mining. It's like open source with Java. And finally, for visualization, I use R and RStudio. After I finished my implementation, I compared my models with the model that usually are made mathematically based on neural network, right? And I expected to reach to higher accuracy. What was the result? I failed. I couldn't find better accuracy in comparison with traditional approach, right? So I came back and looked at my implementation to see what's wrong with my implementation. Can you guess that what was wrong with that? Yes, but at that time I didn't get that one, and I found that the low accuracy is just because I don't have collected enough data, right? Collecting 2 or 3 months data only from Google News is not good enough. So I've started collecting more data from BBC, from CNN, from Reuters, from all of these publishers, and I put a lot of data together, and somehow I created big data. So after I created the big data, I was starting implementing again, but to just find some kind of integrated system, I started learning Python, and I re-implemented all of the things this time with Python. And what was the result? Failed. So I failed again because of the speed. Actually, when I load all of my data into my laptop, I couldn't analyze that data, right? Because that one was very, very big. And even for word-to-vector, which was vectorization, I couldn't run all of the natural language processing process. So what I did, that time I started searching around and find that, okay, Hadoop is very good. Hadoop is very popular. It's like a parallel system. You can split your data on many computers and send your process in parallel to all of these computers, and it will be very fast. So I've started implementing again, and I use Hadoop. And later I found that if I use only my computer to install Hadoop, it doesn't work. I have to have many computers. I install many virtual machines. I had to install many Ubuntu on all of them and configure my Hadoop and rewrite my program because it used another type of program modeling, which is MapReduce. And I've implemented again, this time using Hadoop. And what was the result? Sorry? Yeah, again failed. So I couldn't find better accuracy in comparison with my first approach. So I came back again to my problem, and I look at that one, and I found I have two problems. The first problem is that I cannot take the same period of time for slicing my data, because sometimes something happens, like, for example, when we had an election, the effect on market was only one day, right? After that, it was quite stable. It's one thing. But sometimes, for example, we have some disasters or something that it keeps affecting the market. It was first thing, so I should find some kind of dynamic periods or dynamic slice. The second one was that when something happens, right, there is a span, there is like a gap to affect the market. Sometimes it's 10 minutes, sometimes it's 1 hour, sometimes it's 2 hours. And I didn't know that what's the exact time between when something happens and affects the market. So the problem was that I have to run it many, many times, right, to tune my application, to find the best or optimize my model. So I re-implement that one. This one I use K-mean clustering in Mahout. I've implemented again, and later I found that, okay, there is another technology just coming to market, which is Spark. I had to re-implement this one to Spark to be much faster. And what was the result? Finally, I could find like 1 or 2% better accuracy in comparison with the first approach, first traditional approach. So I had estimated to implement this work in like 2 months, right? But it took me around 8 months to implement this project. So I came back and looked at what I have done. When I look at the things that I've done, I thought that, okay, I know that how should I solve the problem. I know the solution. I also know most of the machine learning algorithms that I need, right? I know that how to do the text mining, vectorization, machine learning, and so on. And I know that how to optimize it. I completely was aware of clustering. So I didn't have to learn something from that part. Most of the things that I had to learn was installation, configuration, and creating some kind of environment for myself to run big data, to analyze big data. So I thought that, okay, am I really a data scientist? Should I do all of these things or not, right? And later, I found that this virtual lab, Data Science Workbench, can really help me because I don't have to install anything. It's on the cloud, and someone else, IBM, is taking care of everything for me. So I just load my data, I start working with that data that I have. So have you registered for that one? It should be now up and running. Good. And I usually don't talk a lot about the architecture of Spark because we are data scientists, right? We don't care that what's happening behind the scenes. And we just try to write our program, and we expect that something else, like the Spark library, take care of everything for us. We don't care that how it will be schedule all of the tasks and how it's going to split our data and so on. But I'm just going to just give you one overview that how it's gonna work. Or later, I just want to put my focus mostly on the way that we do Spark programming, sort of understanding how it does in terms of the parallelism and distribution. Just a few words. So what is the motivation or goal of Apache Spark? The thing is that usually we want to use big data, and we want to analyze big data for making decisions, making some decisions, right? But to perform this kind of data manipulation, querying, and mining, doesn't matter you are doing BI or data mining or machine learning, you always want to have efficiency, and at the same time, you want to run them effectively and simply, right? It should be very simple. But there are some problems. First of all, usually you have low accuracy because you use a small data set. And when you go to a big data set, you have like problem of speed. So always you have to trade off between these two. Another problem is that you couldn't find a general purpose framework, something that can handle different types of data, streaming data, text data, structured data, unstructured data. So you need one environment that can manage all of these things. And it should be very easy, right? I don't know how many of you have worked with MapReduce. Have you worked with MapReduce before to write the Java? Yeah. It's not easy to write MapReduce jobs, right? I used to work with that one. I completely forgot, but I know that it was quite hard to do this kind of MapReduce thing. So what Spark is doing is just make these kind of things parallel. So it go massively distributed and make it parallel. For example, if one task takes T time, when we parallel it, it would definitely take less time than that. The way that MapReduce was working was we split our data in different chunk of data. And we write some reducers to reduce all of them, and we get the output. But it wasn't easy to do that, first of all, because we cannot run iterative algorithms. For example, as you know, clustering is some kind of iterative algorithm. It has to go and run the data and make some centroids in an iterative manner. So every time it has to go to the hard disk and read that one. So Hadoop is not good for that kind of thing. Other than that, it's not interactive. Like you cannot start sending a query and see the result and again send and see the result. Always you have to send as a batch. So Apache Spark has solved this problem of speed, generality, and easy to use. It would be very easy to use. I'm going to show you how it works. So if we have if we consider that we have a clusters and we have many workers on these clusters, right? And we are going to write a program using a Spark. So for example, if I read some files using a Spark.txt file, this file can be a very big file on HDFS, or it can be like a small data set on your local machine. What happens is you create one RDD. After that, you can start creating some other RDDs based on the first RDD, which we call it transformation. And we read all of this data, which are on different blocks. So the whole idea is that we split our data on different workers, right? And we send all of our computation to these workers to do our job for us. So the process is like that. So if I have these workers, I will send the blocks, I will send the task to all of these workers. It will do all of the calculation and send back all of these results to my driver. I can cache my data. If I want to go back and read this data again, I can cache them, the things that we didn't have in Hadoop MapReduce, and I can continue this until I reach to my results. We have two types of operation. The first type is transformation and action. Transformation is usually the things that we do on our data to create a new RDD. For example, imagine that you have a data set of, I don't know, for example, address books, right? It's like a list. And you want to apply something on this list. For example, you want to find all of the duplications. So if you have a list, you have to create another list beside that one. And in the first step, you just trim all of the values, right? So we call it one transformation. In the second transformation, maybe you have to, like if there are some capital letters, you just find lowercase data. So you have to create another RDD, which is another transformation. And at the end, if you want to do some actions, for example, count how many address books you have to do one action. The good things about the Spark is that it doesn't run all of them sequential, right? It's like, we call it laziness. So you just tell the Spark that what you want to do, and it doesn't run all of them until it reaches to actions. As soon as it reaches to actions, it will run all of them for you. So it's transformations and actions that we are going to do. In a second, I will load a notebook, and I will explain that how this transformation and actions would work. So let's go to Data Scientist Workbench and load one of the notebooks that we have. So if you go to Data Scientist Workbench, let me also log into datascientistworkbench.com. Okay, here you are. So when you go to this page, datascientistworkbench.com, click on Login. My computer is a bit slow because I'm sending to another computer, and that computer is sharing the screen. So, yes. So you should see this environment, right? We have different open source tools here. We have MyData is the place that you can store all of your data set there. We have OpenRefine that we use to clean our data, usually is used for pre-processing. We have Jupyter Notebook that we can write our Python code, that behind that one there is a Spark engine that you can send all of your transformation and actions to Spark. We have Zeppelin, which is very similar to Jupyter Notebook, but it has the ability to run the Spark code at the same time, SQL, and visualize your results. We have RStudio. I believe that most of you have worked with RStudio if you are familiar with R programming. We have Seahorse. Seahorse works with Spark, but you don't need to write the code. It's like drag and drop, and you can work with Spark. And text analysis for text mining, right? Today we will work with Jupyter Notebook. Let's open Jupyter Notebook. How many of you are familiar with Jupyter Notebook? Have you worked with Jupyter Notebook? Raise your hand. Just a few of you? Okay. So I will show you one example that's simply just how a notebook works. So the concept of notebooks is like other IDEs, right? An environment that you can write Python code. So when you open the Jupyter Notebook, there is one blue button here, right? You can click on this blue button and select Python. So it will create a new notebook for you. How many of you have worked with Python before? Raise your hand. Okay. What about R? R language? Okay, good. So today we will work with Python. As you know, Spark has different APIs. So if you know Python, Java, R, and Scala, you can work with Spark, right? It supports all of this language. So today I will just work with Python because it's like most popular in the community. So when you open a notebook, you can start writing your code here. It's very simple. For example, I write 2 plus 2, right? And I click on this button, run, and it shows me the result. Very simple, right? For example, A equals to 2, print A. Also, I can click on Shift Enter, that runs that cell and show me the result. The good things about notebooks is that you can add some kind of text, Markdown, or HTML between your cells. For example, I can create a cell on top of that one and write like, it is my first Spark code. And I can turn this cell into Markdown. Right? So it's like self-descriptive notebooks that you can add all of your comments, and also your code into that notebook. You can save it, and you can share it, you can load it, and you can do many things with this notebook. So I've created a notebook already for you. Let's open that notebook and load it to Data Scientist Workbench, and we start writing your code. So let me give you the address and tell you how it works. So please go to this address, https://ibm.box.com/v/intro to Spark. There is a notebook there. Download it. I will tell you how to load it into Data Scientist Workbench. Okay? https://ibm.box.com/v/intro to Spark. Yes. Is it? Okay, let me check. Maybe I wrote it wrongly. Let me check again. So okay, let me download it somewhere else. Yes. So new address would be, let me just put it there. For some reason it doesn't work, but you should be able to download from here. https://ibm.box.com/v/spark intro to. Does it work? Sorry? Okay. You just download it. I will tell you that, yeah, how to load it into Data Scientist Workbench. Just, I want to make sure everyone has downloaded Data Scientist Workbench. Just give me a minute, okay? I will explain to you. Okay, if you have downloaded it, come back to Data Scientist Workbench that I told you, right? And now we want to load this notebook. It's very simple, actually. If you have downloaded it, just drag the file and drop it in this environment, right? Very simple. Just drag and drop it here. It will open into your Data Scientist Workbench. If you have any problem, raise your hand. I can come and help you. Have you got it? No. Spark intro 2, I think. Not intro, Spark. I think Spark intro. No. It's like ibm.com, address.ibm.box.com /v/intro Spark Spark intro 2, right? Here you are. Download it. You guys have loaded? Oh, okay. Mostly the problem is the address. So it's ibm.box.com /spark. You forgot to put case. Spark intro 2. Here you are. Download it. You guys got it? You're good? Okay, sorry. Okay. Are we good? So Spark has 4 libraries, right, which are the most popular libraries of Spark. One is Spark SQL. The second one is Spark Streaming, Graphics, and Machine Learning Library, right? That recently has changed to ML. So we usually use Spark SQL for structured data, okay? Machine learning library for applying all of the classification, clustering, and machine learning algorithms that you want to apply for big data. Graphics for graph processing, and Spark Streaming for streaming data. Today, I just will talk with you about Spark SQL and machine learning library. We will load the data. We apply classification and clustering on that data set. So, first of all, to run a cell, you can use Control-Enter or Shift-Enter, right? To add a new cell, right, we call each of these boxes that you can write the code, we call it cell. If you want to add a cell, you have to click on this area on the blue side and insert a cell above. It creates a cell for you, right? Because later I give you one practice and you have to create this kind of cell. So these are 2 tips that you need. But before we go forward, let me explain that what are these components in Spark. Usually when you want to start writing some code in Spark, the first thing that you have to do is create a Spark context, right? A Spark context is like an object that connects you to your cluster. Definitely for managing this cluster, you need a cluster manager, right? And it's not more than one process. It's one process that are run on a driver program and can manage all of your workers. And all of your tasks will be run through some executors on your workers. The Spark that you have now is local Spark. It means that it's like you have one environment machine on the cloud, and a local Spark has been installed, and you just can use that Spark machine. So what happens? You first submit an application for a process. Driver program is launched. Then we create a Spark context. A Spark context run the cluster manager, and we send all of the data to that cluster manager. Usually, if you work at home, you have to, or other environment, you have to create a Spark context. But here, we have already initialized the Spark context object, so you just can use SC, which is object of Spark context, and you can start working with that one. Let's run one by one. So the first cell that I'm going to run is SC. If you click on Shift Enter, it will show you the result, right? And it means that the object of SC has been initialized. You should see this result. Can you see? Yes? Yeah. Sorry, I didn't get it. For SQL part, you have to initialize the Spark SQL context. Yes. There are some shortcuts also here that I gradually tell you that what kind of shortcut you can use for here. But here we just can write SC and you initialize that one, right? So the next part is sc.version, just to check that what is the version of your SQL context. You can see that we are going to work with Spark 1.6. Okay. So the main part of Spark is RDDs. Right? And RDD is like a list that has been distributed through many workers. But who cares? We just look at it as a list and start working with this list, right? What happens behind the scene, it doesn't matter for data scientists. It has been like transparent to us. So we look at RDDs as some kind of list. And as I explained to you, whatever that you do it with the list, this RDD list, are like lazy evaluation. It means that it records all of the things that you want to do, and at the end, you run that action. So let's run the first example. We create a list. It's like a simple Python list, right? From 1 to 10, and after that, we parallelize this list, and we create an RDD. So the difference between Python list and Spark list, that we call it RDD, is that RDD has been parallelized through many machines, but simple list, which is X, is only on one machine. So let's run it. So it creates one RDD, which is a list that has been parallelized. If you want to look at the first item of this list, you just write dot first, RDD name dot first, right? And it take out the first item of your list and show you. Be careful. When we say that RDD, it can be millions and millions of records, right? And we don't print all of the records in Jupyter Notebook. It will crash. It's why we usually just collect the first row or a few rows of that RDD, right? Let's consider that RDD is a list that has distributed through many machines and has millions and millions of records. So you cannot print it. You just can say that, okay, give me a sample of this list, or first one, or second one. Definitely you can send some actions or transformation to be done on the cluster, but you cannot do it and print it on your Jupyter Notebook. So let's run the first, and it definitely will return the first item of your RDD, which is 1, right? We had a list of 1 to 10, so the first one would be 1. Let's look at 5 items of my RDD. So take will show you some records of your RDD. For example, because here I have put 5, it just returns first to 5 items, right? Next, let's create one list, right, which includes 2 different string values. Hello, human. My name is Spark. So 2 string values in one list. Y is Python list. We convert it to RDD, and then we look at the first one. So you have learned that using parallelized commands, you can do it. You can distribute and create the RDD. So let's make an RDD and look at the first item. Okay, practice time. So create an RDD with number 1 to 100. Then extract first line. Then extract first 5 lines. Then create another RDD with a string of hello, Spark, and extract first line. Just be careful. I put the solution here, right? But please don't look at this, okay? So the solution is here. If you click on toggle solution, you can see the solution, right? But try to do it yourself. You can write your code here and run it. If you have any question, ask me. Candy, also another data scientist in our team, is here to help. So please raise your hand. It's like informal meetup, and we want to just learn how to code. Yes. Have a question? Have you downloaded the file? Where is that? No, just open the folder that the file is there. No. That's it. Just open the folder that your file is there. Showing folder. Yeah. Which folder? Yeah. Now drag and drop. No. Wait. Just drag and drop with the data scientist. Yes. Yes. Here we are. Yeah. Yeah. For sure. Don't worry. So cancel it. Just download this one. You should save it. Okay. Don't open it. Open folder. Yeah. Okay. Have you done? Where is that? It's one of them. It's okay. Yeah, you have downloaded. Yeah, it's okay. Don't open it. So have you gone to datascientistworkbench.com? Go to datascientistworkbench.com. Okay, good. Let's start. You have loaded already? No. Just go to the folder again. Yeah. Select it and drag and drop it here. Loading. Okay. So you can shift into it. Run and it's the result. You're welcome. Yes. Yeah, shift into. Okay. Go forward. It doesn't show your result because you have to not printed anything. Go forward. Go down. Shift enter. This one doesn't have. This one no. This one already you have run, right? Wait. When you shift enter, it's run. Okay. Some shift enter. See, then it's running, right? Okay, it's the result. Okay, let me tell you something. sometimes when you run a cell, right, let's say I'm running this cell, okay? When you run a cell, here instead of a number, you can see one asterisk, right? This asterisk means it's running. So give it the time to finish its work, and after it's finished, it turns to a number. So if you see an asterisk, it means it's running. Okay? You have to wait until it gets it done. So practice is done? No? Why not? The solution also is there. So it's very simple, right? You have to just create a list from 1 to 100. No. Don't write 1, 2, 3. Just use the range. Range is function in Python that can create a range from 1 to 100. Oh, you are writing 1, 2, 3? No. Yeah, so just Google it, okay, how to create a range. So you can create a range from 1 to 100, and after that is one list. Just parallelize that one, create one RDD, and after that, you just create first and second record of that one. Okay, done? Let me do it here. So let me just toggle the solution. I copy and paste. I cheat, but you don't do that. So what's happening here, I just use range function to create numbers from 1 to 100, right? And then I create one RDD. I parallelize the RDD, right? I take first, and I take 5, and that's it. Yes, I will just show you. The best way is just to split in 2 parts. So I will create a new cell. If you just click on A, it's a shortcut to create another cell above that one, right? I click here, okay, it turns to blue, and after that I click on A on my keyboard. So it will create one cell on top of that. I can paste it here and run it. So if you put these 2 codes on top of each other, you don't see the result of the first block. So you have to split it into 2 blocks. Okay, let's go forward. So as I told you, usually we do 2 things with RDD. The first thing is transportation, right, transformation, and the second one is action. So what is transformation? Transformations are some operations on RDD that returns a new RDD. So we have a RDD list, we do something, and it returns another RDD. We have that RDD, we do another thing, a new RDD. So we transform from one RDD to another thing, and at the end we do some actions, right? So what kind of transforms we have? We have map, filter, distinct, flat map, and many other things, right? Instead of explaining each of them, let's practice with them to see how they work. So first, we create another RDD. This RDD is one RDD of text, right? We have a bunch of string values here, 1, 2, 3 values for our list. We parallelize them, and we look at our data. So it's very simple. Just run it, So it's an RDD with three values. It's the first value, second value, and third item, right? Next. We want to apply one transportation on our RDD. So how it works? I have to go through each of these items, right? Item 1, item 2, and item 3, and apply some functions on each of them. For example, if I want to split each of these items, hello human, right, in two items based on the space between them, I have to send my function to each of these items and run it element-wise on each of them, right? Does it make sense? So I have to write a function and send it to this RDD. How can I write this function? I use Lambda. Lambda is a concept of programming in Python, which is exactly the same as functions, but doesn't have any name, right? For example, if I want to have a function that I pass it A and B as input, and output I want to be A plus B, I can write a Lambda function, and it's very simple. I just write Lambda A and B, which is our input. A plus B is our output. So it doesn't have any name. A function that doesn't have any name. Same thing. For example, if I want to take each item of my RDD, right, I call it line as input, and I want to output to be the line that has been splitted based on the space, right? So this part would be input of my function. This one would be output of my function, and my function doesn't have any name, right? So it's like short version of function. So what I do is I say that, okay, take my RDD, word RDD, right, and use map transformation. It means that go to each of the elements of my RDD and apply this function. What is this function? Just split it based on the space, right? So it goes to each of these items, split them based on this space. Let's look at the results. Here you are, right? So it has gone to each of the items and splitted them into two items or three items, depending on how many words we have. Is it easy? Yes? So we use Lambda to apply on each of items of our RDD. We have another concept. It's flat map. The previous one was map, right? Map goes element-wise on each of the items in my list. Flat map is very similar to map, but it goes to each of the items, and the output would be all of the items that have been transformed to one list, right? Regardless of what we had in each item. For example, if I run the same flat map, you can see that this time it has listed all of my items, right? The previous one, it goes to each line and split them. Here, it has splitted all of my items, and I have the list of all of the strings that I had in my RDD. So as you can see, sometimes transformation from one RDD to another RDD will expand our RDD, right? For example, here, the size of my RDD is bigger. It's not exactly the same. Any question? Is it clear? Easy? Good. Is it easier than MapReduce or not? Okay. So let's go forward. Filter function. Another transformation is filtering. Filtering also is very simple in Spark. Just you can write your condition in front of your filter. So for example, here I tell that my input is each line, and my output wants to be this condition. For example, is there any hello word in my line or not, right? You remember we had this RDD. Let me just print my RDD here. It was my RDD, right? I just tell my Spark to go to each of these items and see whether there is a hello world in that or not. So here is my condition. So I run it, it says, yes, there is one of them which has hello. Actually, it returns a new RDD that has only hello, and we count that one, and we print the result. So these are all of the transformations that convert one RDD to another RDD. The next one is action. So already you have worked with different actions, with collect, take, first, show. All of them are actions that you can run on your RDD. So what about if we want to load the data, like we have a data set or we have something, we want to load it into Data Scientist Workbench and start working with a Spark, right? So the first thing that I have to do is download my data into my Data Scientist Workbench. For example, you have one data set which is in Box, is in, I don't know, Dropbox, in Google Drive, somewhere, or on your machine, right? The first thing that you have to do is to bring that data into Data Scientist Workbench and then start working. You have two options to do that. If it's on your local machine, you can simply just drag and drop. If you drag and drop your CSV file or any file that you have, it will be loaded into Data Scientist Workbench. Exactly same way that you have done with the notebooks, right? Just download it, drag and drop. The second way is just, instead of downloading on your local machine and uploading again, just write this line of code, right, which is like a batch code, and this one will download your data and put it into Data Scientist Workbench, right? For example, I have a file that I've shared it into Box, right? Its address is here. And using this command, wget, webget, I just download this text file and I put it into Data Scientist Workbench. So after I load it into Data Scientist Workbench, I read it and convert it into a one RDD. Okay, and I can look at the first line of this text file. If you run, it first will download my data, right? And I look at my first line of my data set. Is this line of text. If you want to look at this data set, you can simply just copy and paste this address first and look at your data if you don't believe me. Okay, I go here and I put it there. You can see that it's a text file. Okay. So what is the first line of this text file? Is Spark Fundamental 1. So what I did here, just I downloaded this one into Data Scientist Workbench. Then I created one RDD from that text file in the second line using Spark context.text file and the address of my file. And finally, I just printed the first line of my RDD. Does it make sense? Good. Now let's do another practice. So there is a file that I've uploaded already into Box, right? Please read, first download that file, right? And read this file and count the number of lines with the word Spark. So you have to do two things. First of all, download it. Second, make an RDD, right? Make an RDD from that file. Then filter it to see whether there is any Spark word into that or not. And then count it. How many times Spark has been repeated in this text file? Go ahead. Let me know if you have any question. If it's hard for you to write, the answer still is there. You can just click on toggle and look at the solution. But please type yourself, okay? Don't copy and paste. Don't let. for reading the file, you have to run code. And it, you can click on this. Mm, what do you mean that, like, you want to use in a private sector? It's free. You can use everywhere. Um, it's like a virtual environment for big data university. For big data university. You know, I show you big data university. We use that environment for big data university. So it's free. You can use for yourself. You can do whatever. Mm. Environment. It's just, for now, yeah, but other like private sectors also are going to use that one. Okay. How different is this one from what you have seen? How different this one is from what you have seen? What's its name, by the way? It's not out there. Like, oh, I see. I haven't heard about that one. Yeah, oh, I see. I see. Yeah, it's good. Okay. Okay. No, we mostly use this one as like a virtual environment because people are keep learning into big data university and they want to practice, so they can load their data here and just practice that one. It's mostly like educational part. Yep. Yeah. Yes. Sure. You can. Okay, I will show you right now. Yeah. So, so the thing is, okay, I will do something, and you don't need to repeat it. Okay. So I open another tab because if you do that, you will lose what you have done so far, right? I just want to show you that how it works. So one of your friends asked that what is the meaning of this, where is this place actually, a slash resources, a slash data, slash these things. When I load something into data scientist workbench, where exactly this file goes, right? And the answer is, as I show you, when you go to data scientist workbench, the first time that you go to data scientist workbench, let me just, size of my window is not the right size now. Let me refresh it. Okay, you remember I showed you that we have my data folder here, right? When you go to my data, you have access to all of the data that you had, right? That place is actually a slash resource, a slash whatever that you have. So it's like a virtual machine, and you can put all of your data inside that. When you write wget, load that data from box and put it into data scientist workbench, it means that put it here in this folder. Yeah, exactly. Yeah. Okay. So wget is actually the Linux command that you just, it's like batch command, right? So, have you done the practice? Yes? Okay, good. So I'm not going to do that part. You just can toggle it and look at the solution and copy and paste. So let's look at the second part, which is Spark SQL. So the RDD concept is very cool. It's very easy to use, but it still is like a bit a low-level structure, right? We want the higher-level structure, and many people used to use SQL. It's very easy for them to write SQL command, right? So it's why we use Spark SQL command. So Spark SQL is like a layer higher than RDD. Usually for structured data, we use Spark SQL. Let's look at one example. Let's say that we have a data set that has this field. This data set, I think, is about some cars, right? Some information about cars. It has mileage per gallon. It has number of cylinders of the cars, displacement, gross horsepower, rear axle ratio, and so on, right? We want to load this data set, and we look at that data, but this time we don't use RDD. We use SQL part of Spark, which we call it Spark SQL. So it's very simple, the same thing, just we load that data. We use this time Panda data frame, right? Panda data frame from Python. Panda data frame is very similar to Spark data frame. And if you want to look at this data, you can write just head of that data frame. So in the first line, I just import the library that I need. Then I read the CSV file, right? Read the CSV file. It means that go to that address and read that CSV file. And empty cars.head just show a few rows, usually 5 rows of my data frame. Okay, so it's just for looking at data, yes? It's very similar to R. Yeah, MTCAR also exists in the R programming, also exists in the Python programming, are same. Yeah, it's the same concept of data frame. Actually, we have data frame in Python, data frame in R, and data frame in Spark. This one is Python data frame, right? And the concept is same as R programming. So it's not a Spark, right? It was pure Python. Now we want to do it in a Spark. How we can do it? We convert this Python data frame, which call it Pandas data frame, to a Spark data frame. We can use SQL context, right, to do it. First, we create one SQL context, right? Just run this cell, and it creates one SQL context. Then we convert empty cars to a Spark data frame. SPF is for a Spark data frame. So I have empty cars, which is a Pandas data frame, a Python data frame. I convert this Panda data frame to a Spark data frame, right? I use create data frame to do this conversion. As soon as I convert, it extracts the schema of my data, right? And schema of my data is car, mileage per gallon, and so on. And also it finds the data type. The cool part about this is that it finds all of the data types. For example, you say that car field is of type of a string, mileage per gallon is double, and so on, right? So I have my SPF. I just can show 5 rows of my SPF here. So as you can see, that same as previous data frame, but this one is a Spark data frame that shows all of information about the cars. Car's name, mileage per gallon, cylinder, displacement, horsepower, and so on, right? And it's much easier than using RDDs. Here is like a data set that you are working with that, right? And most of us have already worked with relational database like MySQL, SQL Server, DB2, and so on. So it's much easier to work with this kind of data frame instead of RDDs, right? So we have loaded our RDD. Now we can start working with data. For example, data manipulation, selecting, and so on. See how easy it is to just select one column. I just write name of my data frame, SDF, the Spark data frame, and select, exactly same as SQL. Select, I want to select only one column, mileage per gallon, and I want to show 5 items of my column. So I run it, and it shows 5 rows of my column. Does that make sense? Good. Now do the practice. Instead of one column, select 2 columns, mileage per gallon and cylinder from your data frame, right? And you write your code here. Done? It's very simple, right? Spark data frame dot select. What we want to select is 2 values. One is MPG, and another one is cylinder. Yes. Oops. Thanks. Why I put double bracket there? Because you are going to select 2 values, right? And it should be a list of the columns that you want. If you just put like mileage per gallon and don't put brackets, right? It cannot understand that it's 2 fields of your data set, right? It worked? Okay, good. It didn't work previously, so maybe it works. I always try to put because in Spark R, I'm sure that you have to put these 2 brackets, otherwise it doesn't work. It's why I usually tell like people who ask me that which one is better, R or Python. I tell them doesn't matter, just learn one of them, right? Because even I sometimes confuse between these 2 syntaxes. But yeah, you can just remove that part and it works. Oh, is it? Okay, good, thanks. Yeah, I think the right way is just to put the bracket because you want to select a list from your data. Anyhow, the next part is filtering data, right? And the filtering also is very simple. You just can tell that which column you want to filter. For example, here I want to filter my data frame based on the mileage per gallon column, and I want to find all of the cars that the mileage per gallon is less than 18. So I can just write my condition here in front of filter, exactly same as RDDs, and I filter my data, right? And it finds all of the rows that its mileage per gallon is less than 18. You can do some operations on the columns. You can use with column command, right, to create a new column. For example, here I created weight in ton, right? And I can run some operations. For example, I can multiply one of the columns by 0.45 to create a new column. As you can see here, it has created one column here, right? Weight in ton, right? And I have put the values here. Just be careful. Spark data frames are immutable. So if you run such a thing, it doesn't mean that you have changed your data frame, right? If you just print again SDF, you can see that that column has gone. So if I just write SDF.show 6, it means you can see that the things that you have done here doesn't appear here, right? So what should I do to fix it? Do you have any idea? So let's say that I want to create a new column and I put some values. Yes? Yes. Yes, you can create a new, create a new variable, actually a new data frame, right? And just drop that data frame to that one, right? It makes sense. So I just can, instead of writing like this, you can say that, for example, STF2 equals to this one. And STF2 is somehow new data frame with extra column. Anyhow. Everything. Everything, yes. Yeah. So the same way that we do the grouping, right? In the SQL, you know that in SQL we can write, for example, select blah, 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 group by something, order by something. We can do it here as well on data frame. So we can group by our data. Here I have grouped group by my data frame by cylinder, and I calculated the average of weights, right? So the command is group by and aggregation, the fields that I want to aggregate. For example, here I want to take weight and aggregate them and show the 5 rows of my data frame. So you can see that the result, I've aggregated my data frame. It shows aggregated by cylinder, 4 cylinders, 6 and 8, and the average value for weight of my cars. Very simple. Also, you can sort them ascendingly or descendingly. You can see that I've sorted them based on count of weights, which is not correct. Actually, I should put something else, like average or something. Anyhow, the count is correct. So it counted how many of cars are of cylinder 8, how many of them are of cylinder 4, and so on. And I have also sorted that one. Let's do one practice, right? Calculate the maximum horsepower by cylinder, order by horsepower. Sorry, just do it. It doesn't have any solution. I think you can do it. What is the highest horsepower? Have you found it? Here you are. You should see the same result as mine. So I've aggregated my data based on the cylinder, and I calculated the average of horsepower, right? It's very simple. Oh, I've written maximum? Sorry. So let's change. I thought that this was just max. That's it. Here you are. I find the same thing? Good. So let's continue. So we have learned how to create the RDDs and work with RDDs, how we create data frames and work with data frames using SQL context, right? Still, it sounds that still people who are working with data sets are not happy with that one. So Spark has created something else that we just is exactly the same as the way that you write the SQL, right? Just writing SQL command. For example, if you want to write select this field from that field, well, blah, 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 still you can use it. So how does it work? First, we have to register our data frame as a table, same as tables that we have in MySQL, SQL Server, and so on. So I have SDF, my data frame. I register that one as a temp table. I call it card. And after that, I can use SQL command to write my SQL, right? And it's exactly the same as the way that you write the select on top of data frame. So in first line, I just register my data frame, right? And in the second line, I just write my SQL command. And the syntax of SQL command is exactly same as SQL command. How many of you have worked with SQL command? I think most of you have worked, right? Okay. So I did the same thing this time with SQL command. So depend on which way is easier for you, working with data frame or with SQL. You can select one of these approaches. Work with data frame or SQL. Or if you are like some people who like to work with assembly programming, you can use RDDs as well. So next part. So we have learned how to load the data, how to create the data frames, and how to work with SQL. We have two other parts that comes from machine learning library. First, we do the logistic regression, and then we use clustering. Before I explain about the logistic regression, are you familiar with the classification? Yes? Is there anyone that doesn't know what the classification is? Okay. Just simply, classification is one approach of machine learning, right? One approach of data mining. When you have a bunch of data and you create a model based on that data to predict some kind of new cases or unforeseen cases. For example, let's say that I have many patients, right? And some of them have cancer, some of them don't, right? I have the record of all of them. What kind of information I collect for these patients? For example, their age, their weight, blood pressure, and so on. And my target is whether they have cancer or no, right? Let's say I have 200 records. I create a model based on that 200 models, right? And if a new patient comes to me, I just use my model based on this new case, and I can predict whether he has cancer or not, right? With definitely some probabilities, like 80% yes, 20% no. It's just the simplest way that I can explain the classification. Classification has different algorithms. One of the algorithms is support vector machine, neural network, decision trees, and one of the famous one is logistic regression, right? So instead of teaching you how logistic regression works, I try to load the data, and we learn it through a data set, a real data set. So we have a data set which is related to many cars and the amount of carbon dioxide that each car emits in like 1 year, I think in 2014 or something. So what I'm going to do, I try to use logistic regression, which is one algorithm of classification, to predict that this car would be emit a high or low emission. So I have two groups, high and low, and I try to predict that one. For example, if I have a new factory, I'm going to try to produce if I'm going to have a new car, before I send it to market, I want to predict whether it's a high emitted dioxide carbon or no. So let's load my data. First, I import all of my library that I need. Then I load my data into data scientist workbench the same way that we have loaded before. And then we look at our data. Our data has these features: make, model, vehicle class, engine size, and so on. And the last one, which is our target, is CO2 emission, dioxide carbon emission, and we are going to work on this value. So let's look at our data first. So I create one RDD, right? And we look at our data. I think already you have learned how to look at the data, right? Look at the RDD. Go ahead and write a few lines of code to look at your data set. Just load the data and look at the first, second, or like a few rows from your data. Okay, you should see this data set, right? So the first row is like the column names, model year, make, and so on. And after that, you can see all of your rows, like model year, name of car, and so on. To create that model, right, you need to do two things. The first thing is just select the features that you are going to make the model based, right? For example, here we are going to make our model only based on cylinder and engine size, right? We call it feature set. And our target, which is the amount of CO2 emission. But if you remember, I told you that what we are going to predict is like binomial values, which is like yes or no, whether it has cancer or no, whether its emission is high or low. So we need a threshold. Excuse me. We need a threshold to just split our data to like high emission and low emission. So, but before we go forward, we have a problem that we have to solve. We have to get rid of this header data, right? Column names, because it doesn't help us for modeling. How we can clean our data? I find the header data and I just filter it, right? So header equals to row my RDD, that's first. So I find the header of my data set here. And then I filter my data set in the second line, right? I say that just filter all of my rows in RDD if they are not equal to header, equal to these values. Also, I split them using comma, right, to make it like a structured data. So if you look at the rows, for example, 2 rows of my RDD now is a list of lists, right, which each list shows one record of my data set. For example, is the first record, second record, and so on. So next step is just selecting the feature or feature selection. But before that, you can do the data exploration, right, to see that what is the like average of each of the features that we are going to use. I'm going to use 2 features. I think number 4 is for cylinder, and number 5 is for engine size, I believe so. And number 12, which is my target, right, the amount of emission. And if I look at the values, you can see that the average of cylinder is 2 point something, I believe that, or 3, yeah, mean is the second one, 3 point something, 5.7, and so on. So let's do the process. So here I do the labeling. Labeling means that if the emission is more than 256, which is like a standard amount, we say that it's low. If it's less than that, we tell it's 1. So it's a type of labeling, right? 0 and 1. Now let's look at the data. So it's our label point. it says that it's on the plus of 0, for example, doesn't have cancer, I don't know, yes, whatever that it is. And these are the feature sets, 2 and 4, for cylinder and engine size. It's the next record. Class is 0, these are feature sets. Class 0, and so on. Definitely, if we look at other rows, more than 5, we can see some of the cars that its emission is higher than that threshold. For example, here we can see 1 or so on. If you want to see more, like I put it here, 50, but you don't do that, it will crash. Okay, so here you can see that here we have 1, right? It means that a car that its engine size, its cylinder is 3.7, and engine size, I think this one is engine size. Its engine size is 3.7, and its cylinder is 6, right? The emission, the dioxide carbon that it has emitted is more than my threshold, right? It's why we have labeled with 1. So we try to use that data to create our model. But before we go forward, we have to split our data set in 2 parts, train set and test set, right? We make our model based on train set, and later we use that model to evaluate using test set, right? So I've split my data into train RDD and test RDD. How I split that one, 70% for training, 30% for testing. Practice. What is the size of train and test set? You can write a 2 line of code to find what's the size of train and test. It's very simple, right? You just can write train.rdd.conf and test.rdd.conf. And you can see you have around 300 something for test. Next part is modeling. And as you can see, modeling in Spark is very simple. It's just 1 line of code. Use logistic regression, and you pass it train RDD, and it can make the model for you. Definitely, the model that you make is just not more than coefficients of your model, right? What's the coefficients of your model? Later, you can use that model to predict. In this cell, I use my model to predict the new case. For example, I have produced a new, manufactured a new car, right? And my car has like 10 cylinders, and its engine size is 5.7. I want to know that it will pass the emission test or not. So I just use my model to predict, yes, for example, or no, it doesn't pass. Here is another case, and you can look all of the test data to see whether it has predicted correctly or not. You can evaluate it, right? We have a command for evaluation. You can just use predict to evaluate your model, and you can find the test error for your model. For example, here my test error is 0.13, which is like around 87%, right? Is the accuracy of my model. You can save your model and use it later. So I tried to explain it. I just have to change this name because I had already saved. The next part is clustering, right? I'm not going to explain a lot. Do you know what's the clustering? Is there anyone that doesn't know what you don't know? You do. Okay. Who doesn't know what's the clustering? All of you are familiar with clustering. So to explain the clustering, I've selected some weather data from Canada, right? In Canada, we have many weather stations, right, across the whole country. And I've selected some data from a company, weather data company, and I try to cluster them based on their distance, right, how close they are to each other, and also based on the temperatures that they are reporting. So as you know that weather is very important in Canada, right? You always, like every morning that we wake up, we check the weather. Okay, it's cold or not today. Whether we need to have something or not to just prevent for cold or something like that. So let's look at the data set first. My data set has ID, latitude, longitude, Parisian, and so on. I will load my data first here. The same thing I will read using wget and load the data. My data set has 1,300 rows, right? And it's a station name, latitude, longitude, and so on. We need to clean our data, same things that we have done for logistic regression. I just simply copy and paste this part. You can also do that part. I just find the header, and I just filter my data, right? So it's like clean data now. I prepare my feature set. Preparing the feature set here is just reading the data, a split based on the comma to make it like a structured data. I select latitude, longitude, and the temperature of the station, right? And I filter them if there is like null value, if the value of temperature or latitude or longitude is null, and I create a very clean data set. So as you can see here, we have the latitude, longitude, and temperature of all of the stations, 1,300 stations. There are some stations that its temperature is crazy, or they are like far from all of the cities. So I will filter out them as well. So if they're like longitude or latitude are farther than what I'm looking at, I will filter them out. And the next step is scaling, right? It doesn't make sense that you do the clustering on some kind of features that they are from different range. Because like longitude and latitude range is different from the temperature, right? Temperature usually change from like -10, -20 to maximum 40, 50, something like that. But the range of values for longitude and latitude is different. So I have to use a kind of normalization to normalize them between, I have to take them under the normalization curve, like -2 something, +2 something. And it's very simple in Spark to do that. I just use the standard scalar to convert them to some standard or normalized value. As you can see, all of them are almost on the same range. Then I apply clustering. By chance, I selected 7. You can change it to 8, 9. Later, we can explain that why we have selected 7, for example. So I made my clusters. I can use my cluster to predict a new station. And let me just evaluate my model and go forward to visualization. So it takes a bit time to do the visualization. I'm going to use Basemap to visualize all of my clusters. Here you are. So you can see that I visualize all of my stations in 7 clusters. Here is my first cluster. All of these stations have like almost same temperature and same latitude and longitude. Here also same, and so on. So there are many different users or applications for this kind of clustering. For example, if I have one station here that is reporting a kind of strange temperature, it might be some kind of faulty sensor or something like that. So people use this kind of clustering of stations for fault detection or something like that. Also, I heard that this kind of clustering is used in oil refineries, I think. Mostly it's just for controlling the sensors, right? to find if there are some kind of values that is out of range, just they can detect that one. So you can select 7, 8, or 9, whatever that you want. It depends on your problem, your domain. For example, in biology, it can be more than that. In gene exploration, usually you have to select a lot of clusters and so on. That's it. I just wanted to show you how you can use Spark to do SQL, to do machine learning, and how you can use different libraries. Last but not least, if you are interested to learn more about the Spark, you can go to Big Data University. I put the link for you here. We have a learning path for Spark, which can click on this link, Spark Fundamental 1 and Spark Fundamental 2, right? And if you're interested to learn Spark using our language, also we have big data with Spark. You can go to the learning path and just learn Spark. Any question about Spark, you can just send me an email. And that's it. Is there any question? Yes, go ahead. Actually, Cluster Manager is sending the task to all of them. Splitting the data, I believe that is done using the Cluster Manager, right? And Cluster Manager will handle the splitting part. No. Just you send, like, it depends on that. It depends on what kind of cluster manager you are using. We have like 4 types of cluster manager, which is like local. You can use Hadoop cluster manager. There is Mesos cluster manager, and so on, right? When you load your data into that, when you send your data to cluster manager, it would split it in different partitions and load it into that one. It's not that you have to do every time. Okay, thank you very much. Thank you for coming. Thanks. Thanks. For sure.